Hi, I'm Mark Wilson, the Engineering Heretic, and today we're going to look at reamers, and in particular I have an 8mm reamer here. I've already drilled a 7.5mm hole, and what I have here in this reamer is basically a brand new reamer, 8mm reamer. It's a chucking reamer, it goes into chuck, but they work the same with any other reamer. And of course this is a machine reamer, not a hand reamer, so I'm talking about machine reamers and not hand reamers at all. I just removed this from its packet. It's a brand new reamer, and I want to ream a hole into this that will take an 8mm dowel and be tight in that hole. And now this particular reamer, because it's brand new, it may well cut oversize. Brand new reamers are a little bit frisky when they're brand new, and these little it just tends to cut oversize. And to go over it onto the bench and explain this a little bit closer as to why these things cut oversize and what you can do about them when they're brand new.
So let's have a closer look on a larger reamer, and I'll point out what's going on here. On the first bit of a machine reamer, this is a machine reamer, not a hand reamer. Hand reamers are quite different up in this area here. On the first little bit, there's this little cutting land, which is just almost like a chamfer. It's a relief, and it's probably a relief of about 15 degrees. But on the outer periphery, on the very outer periphery, it looks like there's a clearance here, and there is actually a clearance there, a primary clearance on this outer periphery here. And if you look closely, you'll see there's another tiny little land past the clearance there, which is not a clearance at all. It's actually a radial thing. In fact, you can even put these, you can buy a reamer oversized if you want a specific size. Put it up, so you buy a reamer slightly oversized. Put it up in a cylindrical grinder between centers and grind this periphery down to the size you want, and actually make yourself a purpose-made size reamer for whatever size you want. So this area here is actually radial, and that's the area that gives you a problem when reamers cut over size. So what you need to do is, on this edge here, it's so razor sharp it will actually cause you issues, and that's what causes the oversizing. So what you do is, normally what I do is grab myself a diamond file, and on that outer edge, just blunt that off. Now I'm not going to do it on this reamer here because it's cutting on size. Okay, so what you do is you just blunt that edge off, so it's not so razor sharp it's going to cause that issue. Try and stay away from this land area here. Don't blunt that off. That actually is the bit that needs to do the cutting. But this area here, this first little land here, is actually radial. It's the bearing area of a reamer, and that's what holds it central. And of course, if the reamer is cutting undersized and you go to pull this back on the quill and you feel it tight in the hole, resisting you lifting it up, you'll have to go the opposite direction. And what I normally do is grab myself a piece of high-speed steel and push this edge the other way, scraping this edge up just a little bit more. And for many, many years, you can actually, well, months anyway, you can actually play around with these things, but only deal with the first little bit of the reamer. If you measure a reamer size, you can measure across the corners here, but you always measure right up at the front there, because there's a very slight back taper on machine reamers, so that it doesn't tend to get bigger. It actually gets smaller in the back here. It's only around about 0.01 of a mil or something. It's very, very small, but there's usually a back taper in these things here. So normally you only have to worry about the first little bit. So you get a brand new reamer, you test it, see what it's cutting at. You may have to blunt the edge outer periphery off. If it's cutting undersized, you may have to push the edge up a little bit with some high-speed steel. But you can play around with these things for many, many times before the reamer becomes unserviceable and you have to replace it.
Now, since we've discussed the reamers and what have you, I have basically got my brand new reamer, and I want to take a bit of an experiment and see if this particular dowel, and dowels are generally a bit about 0.005 oversized, and this particular reamer here is rated for an H7 hole, which is the tolerance rating on the hole for what that reamer is supposed to deliver. I've drilled a 7.5mm hole. I've put some cutting oil on it, and I'll put this in the machine, and we'll just check and see what this reamer is cutting at and what we can do to fix it. Of course, we're running a reamer, and as I just discussed before, because these outer little lips here are radial, they're not a clearance. There is some clearance there, of course, but the actual first little lip there is completely radial. This is a bearing area, and this is what runs and holds the reamer center. So we'll just change the speed to make sure we're not running too fast here. That's a little bit quick, we'll go a little bit slower. Now that's about the right speed there. We'll put a little bit of cutting oil. This is just straight cutting oil. I should have a brush, I suppose, but this is just straight cutting oil. And we're going to ream down a little bit here. Down we come. And this one doesn't have, I don't have any power feeds or anything like that. But reamers you need to run fairly fast, and I can feel that reaming there. Now, once you come down a little bit with the reamer and into the hole a little bit, what you do is you just pull it back a little bit, and if you lift it back, as you lift it back a bit, if this is tight in the hole as you pull it back, you know the reamer is cutting most likely undersized. Now, we're just going to check this and see if it's cutting on size, or whether or not it will deliver a tight fit with the dowel. So we'll just drop that down a little bit, and we'll grab our dowel, and we'll try it in the hole and see if this is actually a tight fit. And of course it's not. It's a loose fit, okay? And we want a tight fit, and because this reamer is brand new, it's actually cutting a little bit oversized. So what I'm going to do is blunt this reamer off a little bit and see if we can achieve a tight fit with this particular reamer. So as we discussed before, this particular reamer here, what we want to do is actually not at the very tip of where the cutting edge is, on this land up here. What we want to do is blunt that off a little bit so it's not so sharp on the edge there, tearing up the edge of the hole there, making this reamer cut a little bit oversized. So just a little bit. I've just got a diamond file here. You can use a stone to do this as well. I'm just blunting off that front edge there, not the little cutting edge down here, blunting that off just a little bit to make this reamer cut a little bit more on size here. Very lightly, and only the first little bit, just where the cutting edge is on the outer periphery. And we just go around to each one just a little bit. We just want to blunt this off just so that it's not so razor sharp on the edge, because that's what the issue is. You can use a stone for this just as easily, but I tend to use a diamond file. And only the first little bit. And let's put this back in the machine and see what we can see if this changes the outcome a little bit better. Let's ream down a little bit further and see if we can tighten up this hole a little bit and make that reamer go, make the dowel go tight. Pull that back a bit, and we'll check this out again. Yeah, now we're achieving something that is tight in the hole, whereas before it was cutting a little bit. So the first little bit is actually a clearance. You can feel it sliding around, but then it goes tight. And of course that's what we want to achieve with this particular reamer there. So now I can continue reaming that hole knowing full well that the dowel is going to be tight. Now the problem happens is, what happens if it's too tight? Now, when you're reaming, if a reamer is too tight, there's a quick little check you can do to make sure it's not going too tight. And that is, what you do is you ream down a little bit, and of course then you lift the reamer up a little bit by hand, and if you can feel resistance, like it's locking in the hole, you're pretty sure this reamer is cutting undersized and tightening up too much on the outer periphery of this reamer here. Now when that happens, we have to kind of do the reverse of what we did before. We need to actually push the edge up a little bit on a reamer. And of course, when you push an edge up, you need to just push it the other way. And in some respects, just push the outer periphery up a little bit on the surface. Now you can use any piece of high-speed steel to do this. I just have a little piece of high-speed steel here that I use for this purpose. And what you do is you actually, on the edge there, you scrape the outer edge and push this edge up a little bit. Sometimes I'm on the bench, I put this on the bench in a vise and push it the other way so that it will restore that edge a little bit. And you only do it the first little, third of the reamer and push this up. Easier on a bench actually. And push the edge of the reamer up the other way, making this edge here a little bit more sharp. You can use carbide for this, but just a piece of high-speed steel will do it more often than not. And then what you do, and keep pushing those edges up, all the way up to this little land here, and you'll find that you'll get just a little bit more life out of this reamer and get the reamer to cut on size again, or sometimes you can even push a little bit too far, and what will happen is the thing will cut oversize. Once you get a reamer cutting on size and you're happy with it, generally a reamer will hold that size for many holes. And once again, if you just keep pulling the quill back a little bit, when you ream down a little bit, just lift it back a little bit. If it's tight in the hole, generally the reamer is cutting undersize. If you push up the edge just a little bit, you can restore that again and get many more holes out of it. And eventually, when this becomes impossible to make cut any better anymore, then you need to either get it sharpened or basically you throw it away and basically get another one, a brand new one. In which case you're going to have another brand new reamer that's going to be a little bit too sharp, generally cut oversize. You'll have to blunt off the outer periphery a little bit whilst it's brand new, and over time push up the edge a little bit over time, and when that becomes impossible to do anymore, throw that one away. And that's the process of getting a reamer to work. Now, if you're a machinist, generally you put things up there, you won't care too much about that. As a tool maker, like I am, I need to know that what I'm doing is actually going to work properly the first time. So the first thing I do, particularly in plastics, so I'm doing ejector pins on injection molds, I will run the reamer down, I will get myself an ejector pin, try it in the hole. If it's too tight, I will push up the edge, okay, a little bit, just to make the thing cut, so that when I put my ejector pin, it runs nice and smooth, because ejector pins generally are undersized where a dowel is slightly oversized. And once I know that my reamer is cutting correctly, then I will go and ream all the ejector pins hole in the injection mold, and basically when I go to put the thing together, which I'm probably likely to do, all the ejector pins will fit the first time. I won't have to hand ream out and play around with it. I just make sure this works for the first time, every time. Saves me a lot of work down the track, and basically gets the job done. And I'm Mark Wilson, and thanks for watching.